Hello, my name is Santiago Bernal, and I'm going to tell you about some properties of the ionized gas in the center of M87 galaxy. We are using MUSE-VLT data and studying the central region in a box of 30 per 30 pixels. We are using the spectra from H-beta to sulfur 2 lines, and for some pixels, we see that lines always separate, but in others not. And in order to determine where this is happening, we use the penalized pixel fitting software. First, we choose one template to fit the spectra and check if the velocity dispersion is less than 250 kilometers per second. And we call this a narrow line. But if not, we use two templates, one for narrow line and another for what we call broad line. So we get the velocity and velocity dispersion of the lines and the weights of the lines that are the normalization parameter of the flux. Then, using the velocity and velocity dispersion from sulfur lines, we fit the rest of the spectra. For errors, we use Monte Carlo simulations and calculate the signal to noise ratio as the value over the standard deviation. Here we see the velocity dispersion maps for narrow lines and for broad lines. And clearly we have a region that has both narrow and broad lines. Here, the line of sight velocity maps tell us that narrow lines are blue shifted while broad lines are red shifted. We calculate the sulfur 2 lines ratio, and here higher values of the ratio means lower values of density. So there are some regions that have higher values of density in the narrow lines, and also a region with higher values of density in broad lines. Then we use the line of sight velocity to divide in regions or box. So from narrow lines velocity, we have regions from A to F, and from broad lines velocity, we have regions from 1 to 4. We sum up the spectra for each pixel in these regions and fit this spectrum. So then we construct the VPT diagrams for these regions. And here we see that broad lines for all the regions have higher values of the oxygen 3 H-beta ratio, as well for the other ratios like the nitrogen 2 H-alpha. But particularly, the broad lines of B and C regions have higher values in all the VPT diagrams. So I'm showing now the VPT diagrams that have consistent results. So in order to explain the behavior of the B and C region, we are now speculating about the mechanism that can be responsible of this behavior. And maybe there is some shocks in the gas ionizing these regions.